Okay, so I have just written down how do we handle irrational numbers. So irrational numbers, many times people end up handling like it's algebra. It's not. It's not a variable that can take any value. It has a very specific value which is hard to represent. So we'll go back to old Indian times where we had Sulpa Sutras, and one of the ways in which they defined, for example, they were making areas, they were making physical shapes. So they had an area and they wanted to get double of its area. So you're making let's say a pond, and you say, okay, I want a pond or I want something, but the area of the base should be twice the area of the previous shape. So they said if you have a square, you want to get twice the area of the square, use the diagonal. As simple as that. So use the diagonal. So the diagonal is also it's a physical length. It's not an abstract idea. It's a physical length you can measure. You make a square, you measure the diagonal, and then you make the area. So we just did this video on what is square and square root, right? So if the area is double, so here if the area is 1 and here if the area is 2, then what is the side? Now 2 is not a nice round number like 4 which has a square root. So you have to represent it as the root of some number, in this case the root of 2. So that's why it's called root 2. And this has a very long trailing number 1.414 and many other digits. Right? So if you want to represent it accurately and you don't want to lose digits, then you need to write it as root 2. If you want an approximate number, then it's okay to use the approximations that you have, first digit, second digit, third decimal place. Yeah? So this is root 2. What is root 3? You have a side of root 2, well, it doesn't look the same, but it's supposed to be the same. And then you have a side of 1 and you have a triangle. Then you have this square plus this square. This square is 2, this square is 1. What is this side? So these are all physical lengths. They are not variables. They are not abstract ideas. Even though if you had root 2 plus 2 root 2, you will get 3 root 2. Yes, you will get 3 root 2. But it's a number. Pause. So if I have root 2 plus 2 root 2, now 2 root 2 is basically root 2 plus root 2. So I'm just writing it down as root 2 plus root 2. So there are 3 root 2's. So 3 root 2. But this is a physical length. So if root 2 is around 1.4, let's say I write 2 in my calculator, or I just write 1.414. So 1.414 times 3, this is approximately equal to 4.242. It's actually a number. It's not a variable. 4 point. So it's a physical length. I take this length and I put 3 of them. That's it. So if I have a length, I have 2 of those lengths, I put them next to each other, it becomes 2 root 2. If I put 3 of them next to each other, it becomes 3 root 2. That's all. Okay, so now I have something like 3 root 2 which I know is a physical length, right? So now I'm going to multiply it by root 2 and see what happens. Okay, so I'm multiplying 3 root 2 by root 2. Now what is 3 root 2? One length of root 2, another length of root 2, third length of root 2. So I have 3 lengths of root 2 and I'm multiplying by root 2 because I'll get areas, right? So if I look at each of these areas, now by the definition of area which we talked about, square, this is actually an area of 2. That's how you get root 2 on both sides. This is one more square of area 2, and this is one more square of area 2. Not drawn very well, but they are all supposed to be the same size and they are all an area of 2. So if you take the total area, when you multiply the 2, you are getting 6. So you are going to get a result of 6. Right? And here too we have our little tricks, that you have 3 root 2 multiplied by root 2. So 3 is a number outside the square root. I cannot mix it up with what is inside the square root. And then I multiply it with all the powers to the half, right, which is square root. So which is 2 times 2. I'm writing upside down, so it's hard, but it's both under square root. So that's as good as having 3 times 2, which is also equal to 6, which is what I got here. So, yeah, they are physical lengths, and I think as long as we remember that, it will make our life easy.